Ooh. Wah, wah, wah. Anyway. Good morning to the day. Next, my chat. Alrighty. So, welcome to another Sunday morning papers. We're just kind of getting ourselves a little set up here. We still have a couple of minutes until go time. Oh. Hope everyone is doing well today. Yeah. Okay. Unnecessary emails are unnecessary. Check. We can have this floating over here. What? What happened to... Wait a second. Hold on there. Oh, okay. There it is. Whew. Sorry, it was just the layout that I have here. For some unknown reason, it was like blocking part of my set of emotes, so I couldn't see my animated one. This guy. Couldn't see that guy. And I like that guy. Good morning. Yeah, we'll see a little more on how they are looking at things. Hold on 1 second. All right, okay, there we go. And you. Excellent. All right. Oh, hey, potato. Good boy. He's a good puppy. Okay. Where are we now? If I do that, is that still visible to you guys? A little bit off. So let me just fix that. That way it's zoomed in enough that I can see it, and it's not so zoomed in that you cannot see it. Huh? Yeah, just what we want. Gotta play that game a little bit. There we go. Now you can see all of the text. Yes, okay. Excellent. Yeah, so let's go ahead and get rolling. Oh, Kiwi. Oh, yawning. I've had so much coffee. Anyway. Okay, so right. So let's go back a little. Okay, so essentially what he has, the valid thing that he has pointed out is that often when people talk abstractly about physical theories or mathematical theories, they talk in terms of things like parsimony or simplicity, as being useful, or as being kind of judgments of what is the most valid, what is the most useful. So, for example, you'll see this lots of times with the idea that the simplest theory is probably true. This is really a growth out of the what's it called Occam's razor, right? And in general, I think it's not a bad approach in that you don't want to start throwing out, or you don't want to start postulating concepts that you don't have support for, right? And so this is a constant sin in philosophy, is that you'll see people throwing out these ontological ideas, these statements about what's real, or theories of how things work, and kind of because they make logical, because they are logically coherent, but that doesn't necessarily make them valid in talking about the world itself, right? Internal logical consistency is not the same thing as validity. So there's this idea, right, that you bring out this concept of simplicity or parsimony as useful ways of looking at theoretical structures and trying to figure out which one is the most effective. But there is a problem with that, which he is pointing out, that that's kind of a heuristic rather than a good means of actually eliminating physical or metaphysical descriptions or ontological descriptions of reality, right? So, in other words, it's kind of a rule of thumb you'd like to follow, but it's not a strict rule of what's going on, because you don't have a full view of everything, right? So in a sense, the problem is one of even if that simplicity and parsimony concept were right, yeah, of course. The yes, right. So obviously, but I'm not just talking about the scientific model as dealing with physical sciences, but there is in a lot of philosophers. I mean, this is what Descartes was railing against with the old metaphysics, the old bad metaphysics, right? Was people would come up with these castles in the air, right? These logically coherent structures that had absolutely no connection to anything. They made no statement that was in any way verifiable or falsifiable. So I think that's, in the end, what happens is, unless you can set up all of these different explanatory frameworks, right? You can set up all of these different theoretical frameworks for how you're going to try and describe reality. But in the end, you have to be kind of stuck in a place where you can't necessarily choose from amongst them, except unless you're very careful in how you choose, right? So something might be a useful theoretic framework for describing XYZ, but it does not necessarily mean that it holds over for this other thing, right? You want to go into in kind of the grounding of philosophy. You kind of want to go to the Hegelian route of saying, well, you don't want to have any presuppositions at all. Well, how do you get to the basic thing so that you avoid exactly those issues, right? That's what Hegel tried to do, and in the Logic. And I really like the beginning of the Logic and how it puts those things forward. He then kind of goes off the rails later on, but the very start of the Logic, I think, is a good approach to doing it. And he kind of does approach it from the simplest possible way. That's what makes it so difficult to write out what's going on and to explain the concepts, because in some ways they're so simple that the building a description of them you've already destroyed the simplicity that's key to the concept, right? That's what's so difficult about talking about pure being and pure nothing, right? Yeah, right? Like, as soon as you start in any way separating them into identities of being and nothing, you've already gone past the starting point, right? So it's and you only see them kind of in retrospect in the way in which they fall into each other. And so I think that's a very good way of approaching. But if you think about it, that is the ultimate simplistic Occam's razor approach to basic metaphysics, right? You want no complexity. It is the exact opposite of any sort of complex structure or setup. So there is a benefit to these concepts, but you do have to be careful, especially in the physical sciences, where those ideas are being ported over to the physical sciences, that those are not valid physical discriminants of a theory, between theories, I should say. Again, in the physical sciences, they're more heuristic. Why are they more of a heuristic? Even if they were, even if you were to take a step back and say, no, these are general rules of theory, right? These, as a general rule, the simpler will always be the most correct. That assumes that you have all of the knowledge of what's going on that you're trying to build a theory about, right? So you could say, and I'm not necessarily wanting to say this, right? Because again, this is starting to import things into reality that, this goes into the fact that people are uncomfortable with uncertainty. But even if you were to say, and I'm just postulating this, I'm just throwing this out there, that Occam's razor is a logical evaluation, right? It's a logical, an exact logical rule. You could only use that if you had access to all possible datum that would go into constructing a theory. And this is why they fail, right? Because when these theories become more complex, it's usually because there was missing, right? The simpler theory was incomplete in some way, right? And we didn't necessarily even know that it was incomplete or why it was incomplete. So good example of this is, the quantum mechanics general relativity disconnect. We know there's a problem, but we don't necessarily know why there's a problem. So we know that the theories that we have are approximations and are overly simplified, but we don't know how exactly and why. So in that sense, right, using Occam's razor is useful, but you have to take it with a grain of salt. And that's why it's a helpful heuristic rather than a general rule, to my mind, right? So, anyway, he wants to, so he's just kind of pointing out the I see the valid thing that's coming out of this paper is sort of that disconnect, right? That's what he's trying to point out. That when philosophers talk about physical theories and when scientists talk about physical theories, they talk about it in very different ways. And partially that's and that disconnect between the kind of those heuristics or philosophers tend to use those heuristics as logical discriminators, which in physical sciences is not necessarily valid because it assumes that we have all of the data available to create a theory, which we know we don't, right? Okay, so let's keep reading. Okay, so another version of the worldview strategy is ontic structural realism. In this view, roughly, there are no things at some fundamental level, and that structure is all there is. Like physicalists, OSRs are concerned to say something about how the non-fundamental or non-physical fits into this picture, and like physicalists, they diverge in how they do this, right? So these two try to accommodate the ontology of the first fundamental sciences, a position called reinforced realism. Stephen French, in contrast, defends an eliminativist position. There are two steps in such a worldview. First, the defense of the general picture itself. Second, the project of accommodating the non-fundamental. It is the first move where continuity with science is typically claimed. So it is this step I focus on below, the notion that the general worldview is supported by our best science. Okay, so they're claiming that the science supports this version, right? And just as I'm about to start, all of that coffee hit. I really have to go to the bathroom. I will be back in 2 minutes. Okie dokie, sorry about that. We're back. Okay, so physicalism, the completeness of physics, and Hempel's dilemma. Let's turn to physicalism first. The claim that the content of physicalism is continuous with science derives from the idea that a weaker but related thesis, the completeness of physics, is empirically well supported. Let's see. C. Popino. Okay, sure. The completeness of physics thesis states that to account for physical phenomena, we only ever need appeal to physical properties, states, and laws. This contrasts with other domains. In psychology, for example, we often have to avert to non-psychological states to explain psychological states. Your current pain, for example, might be explained by the psychological fact that you've stubbed your toe. Physiological states, not psychological. No, this is psychology. Anyway, you have stubbed your toe. Physics is different because the laws of physics, unlike the laws of other disciplines, are universal and complete. Physicalism proper is derived from the completeness of physics by noting that non-physical states have apparently physical effects. Beliefs cause bodily movements, for example, hence ruling out the possibility of systemic overdetermination. These non-physical states must either be identical to physical states or in some appropriate way dependent on physical states or not real. The three possible answers corresponding to reductive, non-reductive, and eliminative forms of physicalism mentioned above. Okay, so let me see. Of these, I would say, this one is more the one that I go for. But the term dependent is doing a lot of heavy lifting there. Anyway. But what, we may ask, do physicalists mean by physics when they say it is complete? One answer, robustly naturalistic, would defer to science. Physical properties and objects are those described in fundamental physics. This answer leads to an obvious problem. Current physics is incomplete. Not only that, there's... I think this is a fallacy of categorization. That's what this feels like to me. Because in reality, these sort of these different areas are not so well defined, right? There is the definitions that we have for physical versus biological, for example, are very, very much human imposed and not necessarily valid in and of themselves. Let's just put it that way. Okay, there are many facts and phenomena unexplained by current science, from sonoluminescence to high temperature superconductivity to the better known examples like quantum gravity, dark matter, and dark energy. It seems reasonable to expect that any future physical theories will need to be revised on account of at least some of these phenomena. And he claimed that everything is physical or dependent on the physical, where physics is understood this way, will be false. I don't think that's a logical argument. Because what's different between what they're saying, that everything is reliant on the physical, and what he's saying is they're talking about the core physical the core sets of physical causes and explanations that occur that are independent of our knowledge of them, right? In other words, even if we have an incomplete physics, that doesn't mean that you can't base your ontological concept as grounded in some way on some complete physics that exists out there. So I don't think this is a valid claim at all. I think he's got things confused. We could then try to define physics by an appeal to future physics. Okay, this will lead to vacuity. Since we have no idea what the content of future physics will be, we can give no clear sense of physicalism defined this way. But you don't need to have a clear idea of the content. Yeah. Right? These things are all interconnected. And this is why emergentism is so interesting, right? Because it's able to explain the differential between the two without divorcing one from the other in such an extreme way. But this is only true if you are trying to make specific claims about things that you don't know, right? That, I would say, is vacuous. but you can talk explicitly about the things we do know and about the gaps in our knowledge without pinning down the gaps, right? So classically, and this is where I agree with him, classically the problem is that people have used a lack of knowledge as somehow a support for their theory, right? I don't know what went bump in the night, so ghosts did it. Great example, right? I don't know what those lights are in the sky. Hey, Gothic! Hey, Gothic! Hey, Gothic! Hey, Gothic! Hey, Gothic! And Mark, good to see you. I hope you guys had a great time with Destiny 2. Well, thank you, Gothic. Yeah, exactly, right. So what we were just talking about is that the difference between, right. So for those who just came in, what this guy is trying to say is that people like appeal to people in philosophy of science, whatever it is, appeal to physics as this idea, and they say, well, everything sort of rests on physics. So all of our theories of mind or of properties or any of these things all really rest on physics, and that's over this complete thing over there, right? Toasty, good to see you. But his point is that how are we defining physics? In a certain sense, physics is kind of an arbitrary definition that we make. One answer is robustly naturalistic, would be to defer to science, right? So philosophically, we're just going to say, that's the realm of the natural scientists, and they have their own thing, right? And then physical properties and objects are those described in fundamental physics. But again, fundamental physics, remember, is an area of study. It's not an ontological category. So it's not a category of being. This answer leaves the obvious problem. Current physics is incomplete. Obviously, there are many facts and phenomena unexplained by current science. Seems reasonable to expect that future physical theories will need to be revised on account of at least some of these phenomena we don't know. So any claim that everything is physical or dependent upon the physical, where physics is understood in this way, will be false. And which is just not a nonsense claim. And he says, we could try to define the physical plan if you appeal to future physics, but this will lead to vacuity since we have no idea what the content of the future physics will be. No, that's not. We can say that there are things we don't know, right? This comes down to that same idea that you have to have some sort of total knowledge to be able to point to it, and you can't point to things as being, explainable within certain bounds, but we don't know how it's explainable, right? So I think this is a completely vacuous argument. To my mind, all things are dependent on the physical. Again, dependent is doing a lot of heavy lifting there, but you don't have to know all of everything to be able to discuss that. That's a silly, yeah. Anyway, so I don't agree with his approach there. This problem that physicalism, so in other words, the idea that everything that exists is in some way grounded in the physical things, right? So it eliminates things like, depending on what version of it eliminates things like the soul or mental kind of psychological things or mental things as things themselves, right? They are purely dependent on or they're just appearances that come up, but really it's just the physical that's going on. And I have a physicalist bent to my personal opinions, but again, I think if you go to an emergentism, you solve a lot of these problems. Anyway, this problem, the physicalism is either false or lacks clear content, is often called Hempel's dilemma, and there is a vast literature that tries to respond to it. Okay. One strategy offered by Andrew Melnick is to take the first horn of the dilemma. According to Melnick, we should define the physical in terms of those theories which are object consensus of current physicists. Although physicalism is defined as likely false, Melnick claims is better supported than any evidence for any alternative metaphysical view, and so is more probable than any of its rivals. This strategy is analogous to Sider's defense of the abductive method in metaphysics and clearly suffers from the same problems. Even if it were true that there is more support for physicalism, so defined, than for its rivals, this would not provide grounds for belief in physicalism if the evidence is in favor remains weak. Right. So in other words, what he's trying to say is that, all right, you can accept that the physical sciences are incomplete, right? But if you accept that they're incomplete, then they can't be a good backing for this theory of physicalism as the best theory we have. And I want to know why. Like, okay, but suppose it's weak, but the best we have, right? Would it not be logical to say that it is the closest approximation we have of the truth? See, this comes down to this idea that you can't have the not yet known in your theory, in your metaphysical theory, and that's just weird to me. But as with Sider, this like, why can't you have something that says it's true in these bounds, right? And again, if you talk to a scientist versus talking to a philosopher, lots of times you'll get this a lot better, that they are very, very, very careful about saying it's what the limits of this knowledge is, right? It's very important. And so you can talk about provisionally, and you can say, we know that this is an approximation, and we can even say we know the ways in which it's an approximation to a certain extent, right? But just even though it is an approximation, hey, it's really effective at explaining X, Y, and Z, and it's predictively powerful in these areas, right? So, yeah, I don't. I think this is an issue that's coming up a lot, but anyway. But with Sider, the situation is even worse than this. Those theories that are object of consensus among physicists include quantum theory, general relativity. Quantum theory and general relativity are clearly incompatible with each other as standardly presented, since amongst other problems, right? So, amongst other things, space-time is curved in general relativity, but flat in quantum mechanics. That is a hyper simplification, but okay. Attempts to combine these theories by quantizing gravitational field by analogy with other fields of quantum field theory leads to impossibilities such as infinite probability values. The probability that such a combination of theories is true must then be zero, and so cannot be the case that Melnick-style physicalism is more probable than its rivals. Okay, sounds good. Appreciate it, Gothic. Enjoy feeding the cat and hopefully cuddling with the cat. Thank you so much for rating in. I appreciate you so much. So again, we can say that our theories, both GR and quantum mechanics, are incomplete right? But incomplete and invalid are two different things, right? We can scope what we mean by our validity. And so we can say, hey, these things are pretty damn accurate within these scopes. We know that's true. We know that's true of Newtonian physics too. Again, Newtonian physics is absolutely fine if you want to do things like launch a satellite. You're going to be using Newtonian physics. Like, most of what NASA does works perfectly well with Newtonian physics. So, as long as we understand what's important is as long as we understand what the bounds of our knowledge are and where things break down, even though we don't necessarily know how things are breaking down, but if we know where things do and don't break down, we can point to them as a valid theory, right? Again, we expect it to be revised in some ways, and we expect those revisions to cause us to rethink certain things about what we thought we knew. We know this, we understand this, but that doesn't make it right. As a physical theory, it still can be a valid physical theory. And so this is his argument doesn't make sense to me, right? Or anyway, an alternative or via negativa. An alternative and more common strategy is called via negativa. Instead of defining physics in physicalism by an appeal to contemporary science, physics is defined negatively as, for example, the not fundamentally mental. Advocates of this view claim that this gives clear content to physicalism in a way that allows metaphysicians to make sense of the traditional mind-body problem. Physicalists think of physics so defined is complete. Dualists deny this. The via negativa converts a sweeping worldview into a rather parochial position, one that forgoes telling us anything of interest outside of the mind-body problem, right? So this is the other, this is the other appeal that you're like, well, we don't know what it is, but we know what it isn't. So we'll use what it isn't to identify what it is. What's that famous thing about the missile? The missile knows where it is by knowing where it isn't. By knowing where it isn't, by subtracting where it isn't from where it is, it knows, like, there's this whole nonsensical, hilarious thing about the missile finding itself. Yeah, right. I don't remember the full quote, but it's exactly like that. And no, again, you're coming down to, what do you mean? You can only do this, right, if you know what counts as physical. So if you're separating out this idea of, right, well, the physical is not the mental. Well, how are you defining the mental? Well, the mental is not the physical. What? You're not, you have no means of defining either or in this case, right? And this is exactly what's so silly about that missile thing, is that so this is just silly. I think, yeah, it's exactly the who's on first gag. That is 100% what it is. Okay. So as he says, and I agree with, the only thing that does is give you interest in the mind body. It says there's a mind body problem. Even so, it is not in fact clear whether this does solve the problem of providing clear content to physicalism, since it remains unclear how to cash out the idea of the non-fundamentally mental. Take, for example, the metaphysics of consciousness, like Chalmers' pan-protopsychism. It seems a case can be made that since the fundamental entities are only proto-consciousness, in Chalmers' view, this conception of how things are is compatible with physicalism defined in terms of the not fundamentally mental. But intuitively, for many, that would seem wrong. Chalmers' pan-proto-psychism is meant to be an archetype of non-physicalist view. I don't know Chalmers' theory. I presume it's something built on the... Just based on the name, I assume it's something based on like the Kantian idea that you don't have access to anything outside of yourself, right? Yeah, it's usually where the non-physicalists end up sitting, is they come back to this idea that, well, everything, right? It's the brain in a vat thing, right? Everything is filtered through yourself. So all of these physics experiments and physics theories that you're coming up with are all filtered through your perception in your brain. So how can you say there's anything outside your perception in your brain, right? You could be the brain in a vat that's being fed in signals and you would have no idea. You could be in the Matrix. But right, so that's usually the anti-physicalist kind of concept, or is that you go back to Kant, who initially pointed this out, that like we can't, as Kant was said, or what Kant said was, you can't actually say anything concrete about the things outside, the things in themselves outside of your perceptions, because all you have is your perceptions, right? You can say that there are things in that there is an impact to your perception, but you can't really say much beyond that. Right. So that's kind of the non-physicalist. So I don't know if that's Chalmers. Yeah. Yeah, he's trying to square the same circle too, right? He's trying to get a way in which you can have what's it called? Synthetic understanding, where you're mixing the two, both the a priori and the post a priori. So both the kind of the logical internal before experience thinking, along with the after experience that comes from the senses, right? He's trying to combine the two, but he's also saying that you don't have access to things in themselves directly through any sort of, in any direct way, right? All of your connection to the outside world is purely indirect, because you only are connecting to it through your senses in the end. Which is a valid position. I think, that's obviously true. But the question is whether you want to say that the senses are referring to, and senses are limited. We know senses are limited, right? You're not looking at things in the ultraviolet right now. But if in any way those senses are connected to an outside reality, that gives you a foothold from which you can start building, right? Start building to the point where you can describe something as being ultraviolet, even though it's outside of the bounds of human experience. No one has ever seen ultraviolet. I take that back. There's a few, actually there's a, there is a genetic variation that allows some people to see into the low ultraviolet. Fascinating. But anyway, regardless, if you want to go into the extreme ultraviolet, you want to go into the infrared, whatever you want to go, right? There are these things that are outside the bounds of human experience that we can start talking about, because as long as the only assumption we have to make is that our senses are in some way connected to a reality. As soon as you can make that connection, you can start building from there. Anyway, One might fiddle with the definition to exclude the fundamentally proto-mental. We might do that when, if we do that, then what about theories of consciousness that envisage revisions and enrichment of fundamental physics, like Roger Penrose's orchestrated objective reduction? No idea what that theory is. I'm just gonna throw it out there. I have not read that. I have no clue. Should we see movies made here as involving a kind of proto-consciousness in the objective reduction of the wave function? What? Should we see the movies here as involving some kind of proto-consciousness in the objective reduction of the wave function? Stipulations might be offered, but it's hard to see what principled answers could be given. I think, yeah, I think this whole side of things is silly anyway, right? I'm physicalist at heart. So I think this, I'm an emergent physicalist at heart, but so I think this whole anti-physicalist effort is just falling over itself from the first place. So it doesn't really matter. Anyway, to my mind, it doesn't really matter. But there is a more fundamental difficulty with the via negativa. It undermines the idea that the content of physicalism is supported by our best sciences. We define physical in terms of physical theory. There is a prima facie, we define the physical in terms of our physical theory. There is prima facie, if somewhat abstract, cease to be for its completeness by appeal to things such as physical laws, as we saw above. Wait, what? There is a prima facie, if somewhat abstract, case. Okay, I missed the noun. Okay, I missed the noun as I was trying to read the sentence, so I apologize for that. Okay, case to be made for its completeness by an appeal to things such as physical laws we saw above. When we turn to the mishmash of things that are included in the not fundamentally mental, it is unclear what empirical or theoretical reason there is to believe in the completeness of that domain, right? So you're not bounding the domain of physics, you're just carving out this circle of the mental and saying, well, this isn't physical. It's not really telling you much. It's unclear what empirical or theoretical reason there is to believe in the completeness of that domain, right? There are obviously many examples of the phenomena we appeal to mental causes seem necessary to explain non-mental phenomena. Conscious mental states are surely one group. Physicalists might assume that these states will be reduced or explained by something not fundamentally mental, but if any such question remain empirically open, they do so in the case of consciousness. There appear to be no empirical grounds to accept the claims of the physicalist. See, this is what emergence gives you. This is exactly what emergence theory gives you. It allows you to have both mental causes and physical causes, and it allows you to interlink them, right? And so you can have both of these things be simultaneously true without one superseding the other. And I think that's the power of emergentism. That's why I think it's so important. Anyway, ontic structure of realism. Physicalists struggle to provide clear content to physicalism because of the incomplete and open-ended nature of current science. Sure. Ontic, so in other words, ontic structural realism. So those who say that what's really there is only structure, right? There's only interrelation, right? So the most basic, so for this group, for this theory, the most basic thing is relation. So this might be oh god, that did a lot of this? You have Whitehead who had it with process, right? So it's similar to process. Whitehead might be a ontic structural realist, although that's kind of in time. He had anyway. Was in part conceived to address similar issues with the philosophy of science, and so might be better placed to offer a coherent worldview genuinely supported by the current science. According to structuralists, Although science, especially physics, is subject to revolutionary change, typically we find that the mathematical structures are retained. I would argue we also find that the theoretical structures are retained, at least approximately through revolutions. So, for example, although the shift from Fresnel's wave theory to Maxwell's electromagnetic theory of light, key metaphysical posits like the ether are jettisoned, the equations Fresnel employed to describe the relative intensities of reflected and refracted light traversing two media are retained, right? So, and again, there are often when you have an expansion of a theory, right? So theories, like I said, are very, very rarely completely discarded. They are usually shown to be true in certain bounds, but not general enough, right? So you tend to generalize things. How do you generalize things? And often you end up discarding discarding kind of ontological claims or requirements that sit there, right? So the problem that existed with this concept of ether was a core misunderstanding in the idea that waves had to have a medium, right? And so waves couldn't self-propagate in the way that light waves can. And so because of that, they had this, they had to have this medium through which light propagated. But the fact that light propagates as waves is still true in both theories, right? Maxwell's electrodynamics has light propagating in waves. And the reason why the Fresnel equations still work is because Fresnel equations are just wave mechanics, right? They're just talking about how waves propagate through different media. The thing that changed was the consequences of, or as you expand the theory, you have to make certain shifts in your understanding of what's real or not real. And you see this again in quantum mechanics, right? Where the ground reality of things are, what it means for something to be in a specific place shifts to this more spread out wave function concept. But that's still, you haven't removed the mechanics of the theory from before. Right. The structural realist says that these mathematical structures it is these mathematical structures that we should be realists about. I mean, we can be realist about the wave mechanics and also be realists about how light is being propagated. Anyway, a distinct ontic form of structural realism, so structural realism dealing with the idea of being, is obtained by combining this kind of realism with some philosophy of physics. Particles are described in non-relativistic quantum theory, as described in non-relativistic quantum theory, have some very strange properties. What one might take naturally to be permutations of different bosons or fermions do not correspond to different physical states according to the theory. Advocates of OSR suggest the best way to make sense of this is to reject the idea that there are any individual particles with intrinsic properties. Instead, our fundamental ontology should include only the structures described by our physics and jettison commitment to fundamental things. But the physics is describing fundamental things, right? It's just what it means to be things changes. They're not being ontological enough about it, right? These structures are our descriptions of something going on. In other words, so the relations within mathematics that are necessary, that are necessarily inherent within mathematics. For example, all of the things that make two. What makes two? Not two of anything, but what gives two-ness? Well, it's the entire structure of mathematics, right? This whole set of interrelations of mathematics is what makes two. Right? So there's an internal structure and realism to that. But when you're applying it to physics, right? It's not, yeah, because otherwise you would just say there's no such thing as physics, there's just abstract mathematics. But physicists make bad mathematicians, and mathematicians often make bad physicists. There's a reason for that, and that's because the you can't just go through these structures. You often have to make assumptions and apply concepts that are exterior to just the structural mechanics of the math. So I think this fails on that count, right? Because physics is not just mathematics; it's its own thing. Okay, what is structure? What though do OSRs mean when they talk about ontic structure? Some statements of the view make it seem utterly mysterious. Quote, if one were asked to present the ontology of the world according to general relativity, one would present the apparatus of differential geometry and the field equations, and then go on to explain the topology and other characteristics of a particular model of these equations. There is nothing more to be said. Okay. But why are you utilizing those equations? Why are you applying those equations? Why those equations? Anyway, this way of expressing what structure is gives rise to the obvious problem of how one can meaningfully distinguish between concrete physical structure from the representing of abstract mathematical structure, the field equations. Yeah, exactly. 100%. In more recent writings, both Ladyman and French seem to agree that the right way to respond to this objection is to admit that there is in the world some causal or nomological structure that is represented by logical and mathematical relationships in our theoretical thought. Okay, so then they've just given away the game. So it is these further nomological or modal facts that differentiate the physical from mathematical structure. But then you've just said there's something outside the structure that's the baseline of what your structure is, that gives validity to your structure. So I don't know, that feels like it's just giving away the game to me. It remains somewhat unclear exactly what this claim amounts to. Yeah, how exactly the modal part permeates the structure, where and how far we might, for example, be able to understand what is meant by these additional modal comments when it comes to the laws of nature. OSRs take a non-Humean view of laws, and these additional non-Humean elements differentiate the laws from the mathematics used to represent them. But even if we were to accept this move, it would not be enough to make the required notion of structure sufficiently determinate. Exactly, right? There's a lot of mathematics that doesn't apply to physics. Anyway, a set of structurally understood non-Humean laws would not by itself be enough to pick out the physical world from all the nomological equivalents. For example, a world exactly like ours, except where the initial distribution of matter to antimatter was reversed. To distinguish two possibilities, the OSRist would have to find a way, right? So in other words, yeah, right? So that's exactly what's going on, right? So the problem with OSR is that you're saying, well, it's only the relations that are real, and you're like, the relations between what? The relations! And the closest thing you get to that is pure mathematics, right? So you can say OSR is a valid explanation of pure mathematics, but it's not necessarily a valid explanation of physics. And so, yeah. Okay. Let's see. How much longer is it? Woo! This keeps going, huh? Okay. So I'm going to call it here for today because we've been going for an hour and I have other stuff to do. Unfortunately, today's very busy. So we will return next Sunday with OSR and the Return of Hempel's Dilemma, section 2.2.2. As we crank our way through the remainder of this. Okay, so he does talk about. He talks in some way about some sort of emergencism, at least a little bit in this way, but anyway, I'm curious to see where he goes. So obviously he doesn't like all of these other theories, right? So he's not advocating for these other theories. But it's fun to go through them and be like, that doesn't make sense. Yeah, so I think there is a way that you can get the. Oops, I don't mean to do it. Yeah, I think emergentism solves a lot of these problems because it allows you to have a physical basis, but also to have things that are directly dependent on the physical, but not exactly be physical, right? So you can have mental states, and you can have one mental state that causes another mental state while accepting that both of those mental states have physical grounding, right? And there's no such thing as a mental state without a physical grounding, right? But you can still have kind of these, you can have what's it called? Efficient causes. So that efficient cause is like billiard ball. Why is billiard ball B moving? Well, it got hit by billiard ball A, right? So the reason why the cause for billiard ball B's motion, say that 5 times fast, is being struck, right? So you can have those in terms of processes of thought, right? So I can go from one thought to another, to another, to another, while at the same time saying that, yeah, but all of these thoughts are riding on physical and physiochemical structures in the brain, right? Both of these things are true. So you have multiple different causes for what's going on in your line of thinking there. You have both the physical and the mental that are kind of running in parallel. And that's why you can have there's mental causes that have physical effects on how the brain is structured. Because that brain structure is necessary for those follow-up thoughts to exist. Yeah, right. There's this right. It's the girl. What is it? The young woman and the old lady visual, or the two people on the lamp visual trick, right? Where depending on how you look at it, it's one, but it's the other, and it kind of like flips back and forth into each other in that sort of way. And so I think that's really what you have, right? It allows you to have this sort of broader concept, emergencism, at least in the setup that I approach it, allows you to have both of these things without contradiction. So that's why I like that version of emergence theory. Because it also means you don't need to posit these extra physical objects either, right? You don't need the soul. You don't need that idea. You don't need this, this disembodied minds concept. It doesn't need to exist. But it doesn't mean, and you can talk about restrictions on the possibility of thought in terms of physical terms, but you also aren't using the physical to describe your process of thought, right? And so it allows your thought to be open in a certain way that's even if you can talk about over like these broad reaching, physical boundaries of thought, you can still talk in ways that you can approach the concept of the boundaries, right, without being in the boundaries. So it allows you to have both of those, and you can bounce between the two, and so it's very, very helpful for that. Anyway, that's my own personal ideas of emergentism and why I think it's useful. And one of these days I'll go back to writing about that. I did write stuff about it a while ago, but I have since been distracted by other things. So eventually maybe I'll get back to getting into philosophy and emergentism. But at any rate, I want to thank you guys so much for joining me on today's Sunday morning papers. I am going to see if Beauty is still on. She is not. Okay. I don't really have anyone. Well, let me look, see if there's anyone interesting to raid that is currently streaming. Often there isn't. Let's see. Category. Nope. Let's see. Oop, that's not what I meant to. There we go. Browse. Categories: science and technology. If someone in French, another person in French. People doing Linux. Building and designing a water level transistor sensor. Choosing next game, finishing Mass Effect. Okay. Let's raid this Irish person who has physics and science and PhD as part of some of their tags. But anyway, let's see. So we want to go. So again, thank you very much. Now, Toasty, I appreciate when you yell at me. It is always appreciated. So we are going to raid tiny toxic tofu. Thank you again for joining me in this wacky insanity that I call streaming. I hope all of you have a wonderful Sunday and week, and we will be back on Wednesday. We'll be back on Wednesday for some more reading of The Hobbit. Yeah. All right. Let's go raid this person. Dooba-doop-boop-boo. Bye, everybody. I've got to go. 4, 3, 2, 1. Raid now.